In this tutorial, I'm going to show you how to read ANOVA tables, or the F distribution tables. In the back of all statistics books, there's a series of tables that look like something like this. And I will go step by step to show you how to do this. I also have another series of videos on how to actually calculate analysis of variance. All the F distribution tables are built upon the same distribution, and the distribution looks something like this. Now, along the horizontal axis is the F ratio, and that's what you calculated with your analysis of variance test. And the actual curve's kind of goofy looking. It doesn't look exactly like a bell curve. And what the body of the table contains is critical values, and that's what you look up in the table. Now, if values that you calculated are greater than the critical value, you fall in the rejection region, and you reject the null hypothesis. If the results that you calculated is less than the critical value, you fail to reject your null hypothesis. Your results should look something like this, and this is the F test. That's what the F stands for. The first value is degrees of freedom of the numerator, and it relates to the number of groups or samples under study. The 12 is the degrees of freedom of the denominator, and it relates to the total number of observations. The 22.59 is the results of the ANOVA, or your F test results. And finally, this P is alpha, and it represents the level of significance, in this case 0.05. Now, across the top of all these tables is the degrees of freedom of the numerator, and it relates to the groups or samples. Along the vertical axis is the degrees of freedom of the denominator, and it relates to the number of observations. And in the body of the table are critical values, all your critical values. Often you'll see tables like this, and across the top are degrees of freedom for the numerator, and on the vertical side of degrees of freedom for the denominator. Notice it has a level of significance of 0.05, which is that 0.05 there. And I'm going to highlight all the red in red, all the critical values for 0.05. Now, also the table has critical values for 0.01, and that's all the bold values in the table. So you have both 0.05 and 0.01 critical values. So it's kind of confusing to say the least. Now I'm going to look up a very specific critical value and show you how to do that. And again, the level of significance is 0.05, and I'll just check that. And that's what that A is equal to 0.05 means, alpha, or level of significance. The first number is the degrees of freedom of the numerator, and that's across the top, or the columns. And it's that column right there, which is the 2 column. The second value we look up is the 12, and that's degrees of freedom of the denominator, and it's row 12. So I'll just fill that in right there. And where they intersect is the critical value, and in this case it's 3.89. So the critical value is 3.89, and I'll draw in my little curve so we can see it. I always like to visualize things. Draw this in, the F ratios, the curve in right there. Now the 3.89 is approximately right here, and that's the critical value. And the rejection region is if the results are larger than 3.89. Obviously they are, it's 22.59. So we reject the null hypothesis. Actually 29.59 is probably way out there. So it turns out I use these tables, and the body of the table is a critical value, and I'm comparing my F test results with some critical value that I look up in the table to see if I reject the null hypothesis. In this case, I do. because the critical value, the F-test results are greater than the critical value. Now, if I have done my tests and my ANOVA results, I should say, are 2 in this case, my 2 is less than 3.89, and I would fail to reject the null hypothesis. So the 2 would be about right there, and the 3.89 is still there. So my F results are less than my critical value. I do have a whole playlist on ANOVA, and I would encourage you to watch the playlist. Share the knowledge on Facebook, Google+, Twitter. Comments and likes below. Favorite us, like us, share us. And don't forget to subscribe because I'm always posting new information.